So it has created a triangle, came back to the origin, created a quadrilateral, then pentagon, hexagon, and then again a heptagon. Hello fellow developers, welcome back to the TechRakshit. I am Amit, and in today's video we shall be talking about Python functions. So in the world of programming, there is a principle called DRY, and which stands for do not repeat yourself. So the main fundamental thing is, eventually if you have repetitive lines of codes that you can bundle into a single function. So for example, if you have, let's talk about some line which maybe prints some name, and if you eventually want to print the same statement for multiple places, in that scenario what you can do, you can simply wrap this thing or the multiple lines of expressions and statements into something called a function, maybe fn1, and within this particular function your logic or your expression and statements can be written, so that whenever you call this particular function, it executes all these expressions and statements written inside this particular function. So in that way, what we can do, we are not writing the same code repetitively. We are not repeating the same code. We are simply writing the bunch of code, the bigger chunk of code, into this function or the function definition basically, and in after that definition we are simply calling this definition. So the engine actually sees this line and it looks for this particular function, this keyword basically, this fn1, and when it finds that okay, there is this fn1 and all the statements and expressions written inside, it simply calls this line by line. Okay, so this is the basic principle of function. Now let's dive into the anatomy of function. So for defining a function in Python, there is a weird keyword which is def. You can think of this as definition, but I do not know why this is def. For other languages, if you are coming from other languages, then it can be function, fn, func, anything. This is weird, but that's how we have to deal with it. Then we gotta provide a name for the function. After that, there should be a colon, and inside this means into the new line you gotta provide an indentation. This is provided using tab or spaces. So this is called indentation, and here in this area you write your expressions and statements. Now this function also needs to provide this bracket here, otherwise we cannot provide any input variable or basically argument. Now what are arguments? Let's take the example of a function like this. So define, my function name is draw, and I'm just providing this bracket. After this there is this colon, and inside this we write our statements. Inside these brackets we can provide arguments. Let's take animal, what animal to draw, and maybe color, what color we want to draw the animal with. So this is called arguments. Now there is this confusion of what is an argument and what is a parameter. Let me clarify that also. While we are defining the function, during that point of time, inside the function we are writing animal, maybe we are using that animal as a variable, or color, as another variable. These two we will call as parameters. From outside, when we are actually calling the function, let's call the function draw, and animal can be a string. Let's take tiger, and the color can be blue. When we are actually calling this particular function, then this value is called argument. So it is argument 1, this is argument 2, like that. Cool. So let's go to the screen and see some examples. Cool. Alright, so I have come to the screen and I have just opened this particular function. Not function, I have opened this particular file, which is functions.py. And here I just want to take the very beautiful example of a module which is turtle. In our childhood, I think we all have worked with logo. There was something logic oriented and graphic oriented. There we used to do this forward, backward, left, right, and all those stuff. So we shall see some visuals. Cool. Not only numbers and text in the console or the print area, we'll see some actual visual. So this turtle can provide a window. Let me just check whether it is providing. Turtle.screen window.title, new window maybe, and we can provide the background color also. BG color, as I am choosing this particular color, has CCC 333. Let's take, because it is slightly grays, darker grays. And if I open this, how can I open this? Window.main loop, and if I run this, I think the window will open. See, there is this beautiful window. Alright, no problem. One problem with this is it is not a parameter. We have to provide this. I think this is my mistake. We gotta provide the title and as a function. We are simply calling this. See, this title, this is a function, and we are calling this using this. See, now the background color is darker and new window is the title. Okay, now let's create some turtle so that we can draw something. Let me just name it Jimmy, then Jimmy dot pen color. Pen color we can make it as white, so has FFF. This is the pen color. And now let me just try whether it is working or not. Jimmy dot forward or FD, let's take 100, it goes. Then Jimmy dot right 90 degree, it rotates 90 degree towards right. And then again Jimmy go to forward for another 100 length. Let's see whether this works or not. Yeah, this works, but for some reason the pen color is not working. I think the same reason is I have to provide it as a function. Now it should work. Cool, it's working. Now for example, if we want to draw an triangle, what we can do, this is my turtle, so Jimmy, what I can say, go forward for 100, then Jimmy, you right or turn right for 120 degree, then again go for 100, again turn right for 120, and then again FD 100. So I think I shall get an equilateral triangle, and that's okay. We can take the use of loops because these are very repetitive. So what else we could have done, for in range 3 and Jimmy is my total name, fd 100, and it also need to do the right. I could do left also, but okay, take right for the example. The loops we can use here, but the problem it is we provide these 3, we have to provide 4 for our, what do you call it, for a quadrilateral, and this right has to be modified to 90 degree, and that's how we can get, how do you call it, this regular polygon. But now let's take the example that if this type of codes are repetitive. Now I want to draw something. Let's take the example of I want to draw a regular polygon of my own size. Like the sides can be 3, 4, it can be quadrilateral, it can be pentagon, hexagon, heptagon, anything. So for that purpose we can write a function. So draw regular polygon. Okay, now this polygon can take some arguments. I would say number of sides as the first argument, because yeah, I want to know how many number of sides does the polygon have. And then we can take a radius as an input from the center to the edge of the regular polygon. Then what we can take another, the tuple for the origin. We can take this as a tuple, so x and y where should be created, and okay, and that's it for now. So let me just write turn angle, because our turtle has to turn, and also here let me just take the TL as turtle, take turtle as another parameter. So turn angle is nothing but the 360 divided by my number of sides. This is simple geometry. Then we need to calculate the length, side length. This will calculate with some logic. For the time being, let me just keep it here. Also, since we have got our turn angle and origin x equal to, let me just put origin 0, because my first argument or first element of origin tuple is x distance, and then y is origin 1. What else we can do? We can just put the name to origin x, and this can be origin y. So for the starting, the turtle has to move to origin x. For that, what we can do, the TL dot pen up, the pen is up, so it won't draw anything. Then TL should go to FD origin x, then the TL should write 90 degree, then TL has to go FD origin y. So now we are not getting this type annotation, so for that what we can do, we can simply provide turtle. So now we can get all the thing. So if we just do TL dot, we shall get all the recommendations. Now it has to do the pen down, and we will write the for loop. Now see here, we have taken these number of sides as a parameter, correct? So we can use this parameter to put the range, number of sides, because we want to complete the polygon also. Now inside these loop, what we can do, it has to turn. So for the first time it has to turn a certain angle, right? Maybe we can write that first turn angle, and it is 90 plus turn angle divided by 2. These are also simple geometry. So my TL dot left, I'm just writing this for that my polygon will be created anti-clockwise. First triangle. Then what you gotta do, TL dot FD side length, then TL dot left turn angle, and it will be done, I guess. Since we have to calculate the side length also, so the side length will be radius times 2 times, we got a need sine function, okay, sine turn angle by 2, we need that. We can import the sine function here, import math, and we can use math.sine. Now the fun part is sine will take the argument of angle as in radian, so we need to convert that into radian. Turn angle in radian or in rad is nothing but math.pi divided by 180, and it has to be multiplied with turn angle. Cool, nothing very fancy. So this radian can be provided here, and my side length is achieved. So using the side length we can create everything. Now we have defined our function, this definition is done, but we gotta call this particular function before my window.main loop is started. So how do you call it? We just write it, then we have to provide the thing. So Jimmy we can provide, because Jimmy is our turtle. Number of sides, what I can do, we can provide 5 maybe, because 5 is for the pentagon. And origin and radius, let's take 100 as the radius, and origin, this is a tuple, so for the first time let's take 0 and 0, because I just want to create the center at the 0 and 0. Moment of truth. Okay, this is done because I have forgot to remove the previous thing. Let's just comment this out also. Simply do it. Cool, the pentagon is created. Now let's take the example of something else. To stop it, if you want to stop it, we just have to close the window. Alright, so let's, instead of 5, let me just provide 8, because I want to create an octagon, and this can be 50 minus 20. Let's see where it creates. Alright, so it is creating, but the origin is not properly chosen, so I have to find where the problem is there. Alright, apparently one thing we forgot to do, that is we gotta provide, once it has arrived at the origin, it has to move to the right side with the radius amount. Let me test it. Yes, now it is creating. Let me just provide 0, 0 and see what it does. For a bigger one, we can provide 250 as the side length. And yes, it is creating at the origin. See, around the origin can be here at this. And if we just want to increase the number of sides from 8 to maybe 30, it will simply approach a circle. And you can see that. Okay, so I have just modified two things. I think I got modified two things. One is after this radius, actually before this forward radius, I have just given this one left 90 because it comes to the proper place or proper orientation, and at the end this TL right first turn angle and TL back radius. This is the final code. The final code will be available at my GitHub, so you can play with it. And now what we can do, we can simply give a triangle with a radius of 250, then we can create a quadrilateral with a radius of 50, a pentagon with a radius of 80 maybe, hexagon 120. All everything are created at the same origin place. So 7, and this time let me put 200, and let's check how it happens, how it works. So it has created a triangle, came back to the origin, created a quadrilateral, then pentagon, hexagon, and then again a heptagon. So see, this beautiful pattern is created using a Python function. Cool, isn't it? Okay, so if you want to draw a little bit bigger, maybe we can change the pen width, pen size, provide with maybe 10. Let's try that. If it is too big, then we have to modify, change it. Ten is okay, I guess, but 5 would have been better. So see, beautiful. Isn't it really beautiful? Using simple geometry at math and Python function, you can create this type of stuff. Okay, two more things I just want to mention. So we have provided all these named arguments. So what if you want to do a little bit differently? So let me just create another instance of the definition of the function, polygon new, and here we are simply taking arg values and args, and all the same thing what we can do, we will copy and paste it here, but instead of these values what we can do, argv then 0 equal to, the first was total, so TL equal to 0th argument, then first argument is number of sides, first argument, then radius is equal to argv, the second index element or the third value, and origin that's how also we can take the values. So this function looks a little bit neat and clean, and I think the same can work here. So I can comment the previous calling, maybe we can copy and instead of all this we can just provide new. Let's check whether this works or not. Cool. So previous functions callings are commented actually. See, the same thing works with arguments also, no problem with that. Cool. So now let me just share how we can take the keyword arguments. That is, I think, would be the last topic. So here we have taken these arg values, okay, but we can use the keyword argument values also. Alright, so now let's see how we can use the keyword arguments instead of arguments to access all the parameters. So we can simply copy the function here and I have pasted. Okay, let me just put a new name, maybe using kew or keyword basically, and these are my keyword arguments. So for keyword arguments, what we can do, and dot we can get by the same key, we have to provide while we are actually calling the function, we have to provide using this particular key. I'll show you how we can do that. So keyword arguments are nothing but a dictionary. So now let me just call, okay, this thing. All the previous function calls are commented, so this is the thing, and this is my new function. We shall be using that. Now here, instead of Jimmy, we have to provide using this, because TL or total is my keyword, then this should be provided as this number of sides, then 200 is the radius, and the end is origin. Okay, so let me just run it. Cool, now it does the same job. The fun and the useful part is you do not need to remember the position. You can provide the number of sides here, radius at the second, and then also it can be called, and the result is same. So this is the beauty of keyword arguments. Cool, I think that is it for this lecture, and hope you have enjoyed and liked. So if you enjoy, please give it a like and subscribe to the channel. Thank you very much. I'll see you in my next video.